Light itself tried to escape this star. It failed for 9 hours. Our sun? Light circles it in 14 seconds. Stephenson 2-18, 9 hours. The same light, the same absolute speed limit of the universe, turned into a prisoner crawling across a surface. And it's in our own galaxy, 20,000 light years away. In a few minutes, I'm going to put you inside this star. You'll watch Jupiter, the giant that almost became a star itself, dissolve like a raindrop in the ocean. And then I'm going to show you something nobody ever tells you about this star. Something that changes everything. Because there's a chance, a real scientific chance, that Stephenson 2-18 isn't even the biggest star I'm about to describe to you. The first time I understood what Stephenson 2-18 really was, I had to close my laptop and go for a walk. Not out of fear, out of vertigo. Because after that, the night sky never meant the same thing to me again. I want you to feel that too. Let's start with what you already know. Our sun, 1.3 million times Earth's volume. Its surface roars at 5,500 degrees. For millennia, entire civilizations worshipped it as a god. It's trivial, but numbers won't do this for you. Numbers stay in your head, clean and safe. So let me show you. You're in space, between Mars and the asteroid belt. Absolute vacuum. Behind you, the sun shines like a distant lamp. Stephenson 2-18 appears. No explosion, no sound. There's never sound in space, just a wall. A wall of scarlet plasma in every direction, as far as your eyes can see. The entire universe replaced by molten stellar flesh. You're no longer in space. You're inside a star. Now, why does light crawl? In 7 heartbeats, light circles Earth. In 14 seconds, it circles our sun. That's the fundamental law of reality. Nothing can go faster. Point that same beam at the equator of Stephenson 2-18. 8 hours, 45 minutes. The length of a Paris to New York flight. While you sleep tonight, light will painstakingly trace a circle around a single star. This isn't just bigness. It's a violation of physics. Something that should never have existed. And if you flew a commercial jet along its surface at cruising speed, it would take about 500 years of non-stop flight to return to your starting point. But that number still doesn't tell you what this does to our solar system. So I'm going to show you, planet by planet. And when I get to Jupiter, in exactly 2 minutes, you're going to see something that made me physically uncomfortable the first time I understood it. Stephenson 2-18 materializes in place of the sun. 0 delay, 0 warning. Mercury, atomized in a fraction of a millisecond. 4 billion years of existence erased before the star even notices. Venus, its hellish surface, its toxic atmosphere, all of it becomes meaningless, swallowed without a ripple. Earth, every civilization, every war, every child who ever laughed. We don't explode in dramatic flames. We simply become a few more atoms in an ocean of fire. Not even a surface ripple. Mars, the entire asteroid belt vaporized. Jupiter, the guardian of the solar system. A world so massive, it contains more matter than all the other planets combined. A colossus whose storms have raged for centuries. A giant that could almost have become a star. Swept beneath the surface of Stephenson 2-18 like ash in a firestorm. Dissolved. Anonymous. Jupiter is gone. The ocean of fire keeps going. Saturn and its rings, the rings Galileo first observed 400 years ago, swallowed without a trace. Uranus, Neptune. The solar system no longer exists. One single star, 8 planets, 0 survivors. Here's what nobody tells you. Stephenson 218 is dying, not in billions of years, on cosmic timescales, in the blink of an eye. 100,000 years, maybe less. The largest star in our neighborhood of the universe is living on borrowed time, and it knows it. It is bleeding into space. Millions of tons of its own matter are torn from its surface every second. It is wrapping itself in a shroud made from its own entrails. This is exactly what stars do before dying as red supergiants. Their stellar wind carries away a colossal mass, creating shells of gas and dust that sometimes stretch for light years around them. Imagine a wounded animal, too enormous to die all at once. So it bleeds out, slowly, through every pore, waiting for the final moment. Remember Jupiter, a moment ago? The giant that almost became a star. Stephenson 218 actually pulled it off. And look where that got it. Dying faster than almost anything else in the universe. I promised you something nobody tells you. Here it is. Stephenson 218 might not even be that big. Everything I just told you. The 9 hours of light, Saturn's orbit swallowed whole, the 500 years of flight, rests on a single number, a radius of 2,150 times that of the Sun. And that number, nobody is actually sure of it. Here's the problem. To calculate a star's true size, astronomers need to know its distance precisely. For Stephenson 2-18, that distance carries an uncertainty of more than 50%. 50%. Imagine measuring the height of a building without even being sure whether it's 500 meters or 1 kilometer away from you. And it gets worse. Current theoretical models in stellar physics set a limit. No red supergiant should exceed about 1,500 times the Sun's radius. Beyond that, the star's internal structure should become unstable. Stephenson 218, at 2,150 solar radii, exceeds that theoretical limit by 40%. So either Stephenson 218 breaks the known laws of stellar physics, or it isn't as big as we think, and the real record holder is somewhere else. NML Cygni, a red hypergiant in the constellation Cygnus. Some scientific estimates place it at 2,770 solar radii, even bigger than Stephenson 2-18. Other measurements of the very same star bring it down to just 1,183 solar radii. For one single star, that's a factor of more than 2. The title of Clargest known star has changed hands at least 6 times since 2012. NML Cygni, and then UY Scuti, then Westerlund 1-26, then UY Scuti again, then WOHG 64. Every new study, every new distance measurement reshuffles the deck. Which raises a dizzying question. What if the largest star in the universe doesn't even have a name in our catalogs yet? Here's the uncomfortable truth that videos about the biggest star in the universe almost never tell you. That title isn't a fact. It's a blurry photograph, taken from 20,000 light years away, through clouds of interstellar dust, with a margin of error that science itself refuses to hide. There's an even deeper doubt. Some astronomers question whether Stephenson 2-18 actually belongs to the Stephenson 2 star cluster it has always been classified in. Its radial velocity doesn't quite match the rest of the group. If it isn't part of the cluster, its distance, and therefore its size, could be completely different from what we've always believed. It's like spending years measuring a giant's height, only to realize you're not even sure which room of the house it's standing in. So what would the inside of Stephenson 2-18 actually look like if you were really there? The honest answer: a wall of scarlet plasma, identical to what I described at the start. Whether its exact radius is 2,150 or 1,500 times that of the Sun, the result is the same for you: a tiny human dropped inside. Death would be instant, silent, and the entire universe would be replaced by fire. What changes isn't the experience, it's our certainty. And that might be the most uncomfortable lesson of all. We've photographed galaxies 13 billion light years away, yet we can't say for certain which is the largest star in our own galaxy. I told you, right at the start, that the night sky never looked the same to me after understanding this. Now you know why. It isn't just the size of Stephenson 2-18 that's dizzying. It's realizing that we're looking at the universe through a fogged-up window, and that even our greatest records are written in pencil, not ink. If a star can be twice as big or twice as small, depending on which study you read, what do we actually know for certain about the universe? Tell me in the comments which other certainty cosmic you'd like me to challenge in a future video.